Hello students, welcome back. So in this session, I'm going to show you the need for NumPy arrays for numeric computation. So I'm going to compare your NumPy array over Python list. And I'm going to show you how your NumPy outperforms your regular Python list in both your memory and your computation speed. And also I'm going to show you that NumPy syntax is very easy. So first we import our libraries, NumPy, time, random, sys, math. Time I'll be using to time my operation just to show you how fast that is. I'll be generating some random numbers. Sys, I'm importing this get size of just to check the size of my objects. Okay, so let's check the size of the object first. This is my number of elements. I create a list from 0 to 100 over here. In this case, it's 100 elements. I print my list and then I check the size of my list right here. And so this is my list right here, 0 to 99, total 100 elements. And look at that, it's 856 bytes when I'm using list right there. On the other hand, when I convert this list into a NumPy array and I check the size of my memory, look at that, 512 bytes. That's almost 50% drop in size. You can change this number to maybe, let's say, this right here. So if I change this to this number, which is wow, 100,000, I run this. And oh, look at that. Let me just comment this line out. This is going to be printing everything out. Okay. Now look at the size. Big size, small size, almost 50% drop in your numbers. Okay. Then let's just look at performance on the element-wise addition. So we're going to add a number to all the elements of a list and also in a NumPy array. And then we're going to see how much time it took. So let's add a number to all elements in a list first. Let's start with the list. So let's say my number of elements is this, almost 10 millions. And I create a list first. Then I start my timer over here. I create an empty list. And my for E element, it's going to go through this X list right here. And it's going to add to each element, it's going to add 100 to that. And then at the end, I'm going to check my end time. Then I'm going to just print the difference between my end time and a start time. That will tell me how much time it took. And then I'm also going to print my X less new first 10 elements and first 10 elements of both of them. And let's run this. And it took me approximately 0.71875. So this is my original list right here, this one. And I added 100 to each one of the elements. So 0 plus 100 is 100, 1 plus 100 is 101, 2 plus 100 is 102. So that's what happened. I just added 100 to each one of them. And it took me 0.71875 seconds. Let's do the same thing in NumPy. So I create my list, convert my list into NumPy array, start my process, timer, check what time it started, and look at the syntax. All I have to do is say x numpy plus 100 over here. That's interesting. And that's very good too, because over here, look at this right here. I actually had to create a for loop right there. Out here, I'm not creating any for loop. I'm just saying x numpy plus 100, and that's gonna add 100 to every single element over there. Then I check my end time, and I print my difference between the end time and a start time. That will tell me how much time it took. In this case, it took 0.109375. So let's see how fast that was. So let's divide this this number, which is right here, this divided by this number right here. And let's run this and look at that, 6.5 times faster. All right, so your NumPy is 6.5 times faster than your Python. Pretty fast. All right, let's look at an element-wise square now. Instead of adding numbers, now I'm going to take square of every single numbers. Create a number of elements is 10 million. Create a list of 10 million elements. Start my process time. Create an empty list. Iterate through each element in my X list. and for each element, square it, and then add that, append that to your x new, and then at the end, you check how much time it took over here, and then you print the difference. And let's run this, and let's see how long it took you. Okay, this took 1.5625 seconds. Now let's do the same thing with your NumPy array. So I'm taking my number of elements, same thing, create my list, convert my list to NumPy array right here, and then start my time. Look at the syntax. All I have to do is some x NumPy to the power of 2. That's all I have to do. I don't have to create any for loop over here. That's very neat syntax. And then you end time. Check your end time. Check the difference between end and start is this right here. NumPy did not use any for loop and it is faster. Well, how fast it is? Well, let's look at it. Take this number, right? Copy this, come down, put this over there, divided by this number. All right, let's run this. Look at that, 11 times faster. All right, now let's look at the performance on addition of two vectors. So I'm going to start with the Python list. So in this case, I have two vectors. I created two vectors. This is my first vector, and number of elements is 10 million. And this is my second vector right here. Okay. Start my time. Check what time my process started. Look at the result. Okay, this one actually is using list comprehension right here. Okay, it's taking elements, each element over here in list one, and checking each corresponding element in list two, and it's adding them together, just doing vector addition. So then I check my end time, and I print my difference between the end time and start time, and just to see how much time it took. It took me 1.47 seconds approximately. Let's do the same thing using NumPy array. So, oh, look at that. It was very fast. Array 1, I'm basically just creating a range of numbers, creating a range of numbers, 10 million in this case, start time, and look at that my result array. In this case, I used list comprehension right here. I did not use any for loop over here. Look at that. All you're doing is saying array 1 plus array 2. So this is going to perform your vectorized operation. So NumPy is not using any for loop over here. Check what time your process ended, print the difference between end and start, and your answer is 0.035. NumPy did not use a for loop. But how fast was it? Well, let's check. So this is 1.471. Let me copy this, put this over here. Let me copy this and divide by that number. And let's run this cell. And the answer is 42. It's 42 times faster. NumPy was 42 times faster. That's amazing. Now let's look at this thing. Performance on matrix multiplication. So a lot of times in your numeric computation, matrix multiplication is a very common operation. So let's see how Python does in matrix multiplication. So I have a matrix A. Let's say I'm creating an 300, a matrix of size 300. So create a matrix A. Actually, let me run this for a second. So what I'm doing, I'm creating a matrix A right here. And as you can see, it's using list comprehension right here. I'm also creating a matrix B. And then I'm creating some empty matrix right here. And start your time. And then for I in range n, for j in range n, for k in range n. Basically, I'm just creating, multiplying these two elements from these two matrices. And this logic is I'm using to multiply the corresponding elements from these two lists. And then I check my end time. And then I print my end minus start. And look at that. It took me 13.59 seconds. And look at this. I had to create one for loop, another for loop, another for loop, three for loops. Now let's do the same thing in NumPy. Okay, so this is my array NumPy. Okay, this is going to be size n comma n. And size, what was my n in this case? Go back and check 300. So it's going to create 300 by 300 matrix A and B, and start your start time, like check what time your process started. And this is the way you actually multiply matrix in NumPy. So A and P at the rate of B and P, that's going to multiply these two matrices. Look, I'm using no for loop over here. You see that over here I had to use for loop to implement the logic of matrix multiplication. Over here I'm not doing none of that. And then end equal to end time and check the difference. And how much time? Oh, look at that. It was fast. 0.1005. How fast was it? Let's verify. 13.59. Copy. Paste it over here. Divide by 0.1005. Come over here. Paste it over here. And let me just put point. Run this. 135 times faster. That is amazing. All right, let's look at some statistics operation, how it fares in the statistics operation. So let's calculate mean, sum, maximum, standard deviation using Python list. So let's create a size of a list, a Python list with 10 million elements. So I'm using list comprehension to create that. Print my size over here. So start your timer, like what time it started. And then you create a sum first. Okay, you basically, there's a method called sum, and you pass in your list over there. That's going to add all the elements. And then you can find your mean. You find a mean by taking the sum divided by the total length. Okay, you find your maximum. There's a max function that's going to find the maximum on the list. Then you find your standard deviation. So in this case, Python does not provide you the direct way to calculate standard deviation, so I'm using math library. So I'm using the standard deviation formula right there, and then end time right there. And then I print my p1 end time minus start end difference between end time and a start time. And it takes me approximately, let's see, it's still running right now. And so it's going to print out my mean, sum, maximum, standard deviation. And at the end, it's going to print out how much time it took. So in this case, it took me 4.44 seconds. All right, now let's do the same thing using NumPy. So I come over here, create my NumPy array, exactly same size as my Python list, create my start timer. So the way you calculate mean is there's an inbuilt method called np.mean. That's going to calculate the mean. Same thing with your sum, same thing with your maximum, and same thing with your standard deviation. So I'm using Python, using NumPy's inbuilt method to calculate these statistics. Then my end time is right here. Calculate the time difference, and then print out your result. NumPy result. And time it took me is 0.14058. So what is the difference? Well, that will give you a speed of time. So NumPy is approximately 31.62 times faster than your pure Python. So this should convince you to use NumPy array when you're doing numeric computations over Python list. Thank you, gentlemen.